Good morning. Today we will continue our discussion on resistance. As we have already studied that resistance is the opposition faced by the electrons while moving from one end to the other end of the conductor. Now this opposition or hindrance, as we may call it, is primarily due to the collisions, the frequent collisions what an electron undergoes in its due course of motion. Now the question arises, what are the factors that is ultimately going to decide what should be the resistance in any circuit? So that would be the topic of discussion for today's session. We will be studying about the different types of resistances, what are the different factors that ultimately affect resistance, and last but not the least, we'll be studying that if number of resistances is more than one in any circuit, then how we are going to connect them, like the possible ways of combining different resistors. So we'll be studying about the different types of combination of resistances. Okay, so let's begin by studying what are the different types of resistors. Types of resistances. Resistors are of two types. They may be fixed or variable. Now the variable resistances are also known as rheostat. So let's study a bit more about these two. Fixed resistances, their value does not change under constant physical conditions. They are set at a particular value. You can see the picture of these fixed resistors in the screen. I hope you have seen these type of resistors being used in many electric circuits, isn't it? They come and are easily available in the market. They are of different values. So as per our requirement, we connect these sort of resistors in many electric circuits. Now, if suppose we want to change the value of resistance in any circuit, then this is not possible by connecting fixed resistors. For that, we require a variable resistance, or what is commonly known as a rheostat. The picture of rheostat is also coming on your screen. Now the resistance can be easily changed by changing area of cross section and length. Now you might be wondering that how it is possible to change the resistance of any resistor, that is a rheostat. Let me show you a video. Let me zoom it a little bit so that it becomes properly visible to you all. See a simple circuit in which a rheostat is connected, and see how the wiper is moving the slider and the brightness of the bulb is getting reduced, isn't it? So by simply moving the wiper from one end to the other end, see it is coming back. Now the brightness of the bulb is increasing. This means this is the position for minimum resistance. And as it moves towards the other end, the brightness is reduced. See. So simply by moving the slider, the wiper of the rheostat, one can adjust the resistance. Okay. So that's how we are having two types of resistances. Okay. Look in this picture. What can you see? Flowing charged particles. Now as these electrons are moving through this section of the conductor, you can see how the resistance is offering an opposition, how the resistor is actually slowing the flow of electrons, isn't it? So next we will be studying what are the factors that is ultimately going to increase the value of resistance or change the value of resistance in any circuit. Now just consider this example. What if the length of a conductor through which the current is supposedly flowing is increased? What is going to happen? Will it be a smooth ride for the electrons, or it will have to face more number of collisions? Obviously, longer is the path, more is the possibility of colliding against each other. So, to have a smooth flow of electrons so as to face minimal resistance, it is essential that the circuit should be as compact as possible. So, resistance is directly proportional to the length of the conductor. This means more is the length, more is the resistance, and lesser is the length, lesser is the resistance. Now just see how area is affecting resistance. See, when the path narrows, what happens? Just now the electrons are flowing so smoothly, and as soon as the path narrows, see how they are confined, how the possibility of collisions has increased. So, what type of a dependence it is? A direct or inverse? Obviously inverse. Resistance inversely depends upon the thickness of the conductor. See, as the thickness decreases, resistance increases. So resistance is inversely proportional to area. Now a question. Apart from length and area, what could be another factor that could play a dominant role in deciding resistance? Let's see. See this picture. You can see three situations, three ways in which the particles are vibrating. Now, what is the basic difference in these three situations? The temperature. In the first situation, the temperature is quite low, and so the particles are having minimal energy. In the second situation, the temperature is slightly more, so the particles are vibrating a little more. And in the last picture, the temperature is having the maximum value, so the particles are having maximum energy, and hence the vibration is also maximum. This means with an increase in temperature, we can directly increase the energy. What type of energy? Kinetic energy. So more is the temperature, more is the kinetic energy, more would be the vibration, and more would be the possibility of collision. So temperature has a direct effect on resistance of a conductor. More is the temperature, more is the resistance. So let's combine all these factors and reach to a common conclusion. We have seen that resistance is directly proportional to length and resistance is inversely proportional to area of cross section. Combining these two, we get resistance proportional to L upon A. Now if you want to replace this proportionality sign with an equal to sign, we have to introduce a constant, and that constant is given by the Greek alphabet rho. So resistance is equal to rho L by A. This is one more expression for resistance that you need to remember. Now what was the pronunciation? It is called rho, and it stands for resistivity. Resistivity or specific resistance of a material. Okay, so rho is called resistivity or specific resistance of a material. Let's define it. Resistivity or specific resistance. Now, in order to define it, let's first of all obtain its formula. Now, as we all know that R is equal to rho L upon A. So, very quickly we can get rho equal to R A divided by L, isn't it? Now, if length of the conductor is 1 meter and area of the conductor is 1 square meter, what will happen? Rho will be equal to R, isn't it? In this formula, if you put E equal to 1 and L equal to 1, then obviously rho will be equal to R, but that will be numerically, isn't it? So using this situation, we can define specific resistance or resistivity as this. Resistivity is numerically equal to the resistance of a conductor of unit length and unit area of cross section. Now we obtained an expression for resistivity. So very quickly then we can obtain the unit. So what should be the unit? For resistance, the unit is ohm. For area, it is meter square, and for length it is meter. So cancelling out, we are left with the SI unit for resistivity, and that is ohm meter. And how can we symbolically represent it? Ohm meter is symbolically represented as this. Okay. Now as I was telling you that if suppose we require more number of resistors in a circuit, then how to combine them? Combination of resistances. Now there are two ways of connecting the resistors. What are they? The first one is a series combination, and the second one is a parallel combination. So in two ways we can connect the resistors in any circuit: series combination and parallel combination. So one by one let us study about the manner in which resistors will be connected in series and in parallel. Series combination of resistances. See, a circuit diagram has been shown that will help you to understand how we can connect the resistors in series. In this circuit, I am showing three resistors of values R1, R2 and R3 being connected in series. Apart from these three, what are the other circuit elements connected in this circuit? There is an ammeter, a battery, a key and a voltmeter. Okay, so these circuit elements are also connected in this circuit. Now let's first of all define and understand what basically a series combination is. So when two or more resistors are connected end to end consecutively, they are said to be connected in series. When a number of resistors connected in series are joined to the terminal of a battery, then each resistance has a different potential difference across its ends, which depends on the value of resistance. But the total potential difference across all the ends of all the resistors in series is equal. Now let us understand this a little bit. See, when the resistors are connected end to end, then the battery, if it is providing a potential of V, then the potential drop across each resistor is going to be different. Like suppose if the resistance R1, across R1 the potential drop is V1, if across R2 the potential drop is V2, and if across R3 the potential drop is V3, then V will be equal to V1 plus V2 plus V3. Okay, next, when a number of resistors are connected in series, then the same current flows through each resistance. Now see, is there any separate path for the flow of current? You can see the direction of current has been shown over here and here. So the current is flowing in this direction, and see there is only one path through which the current can flow, and that is through all the resistors. So through all the resistors the same current is flowing, and that is coming back. So I current is flowing in this part, see, and total current I is returning. So same current flows through all the resistors. So the potential drop across each resistance is going to be different, but the current flowing through every resistance is going to be same. Now let us obtain an expression for the total resistance of the circuit. Like when three resistors of three different values are connected in series, then what should be the total resistance? Following this same diagram, we can obtain an expression for the total resistance. Let's proceed. As V is equal to V1 plus V2 plus V3. So, using Ohm's law, V1 will be equal to how much? V1 is equal to I into R1. See, I current is flowing, then the resistance is R1. So, V1 is I R1. Similarly, V2 will be I R2 and V3 will be I R3. So, what about V? V should be I into R, where R is the equivalent resistance. Now, since the resistors are joined in series, so let us put a subscript S. So, IRS. RS stands for total current I and RS is the equivalent resistance. So, this is the expression. Now, IRS will be equal to I. We can take out I as common and then R1 plus R2 plus R3, isn't it? So now you can cancel out I from both the sides, and this will be the expression for equivalent resistance. Rs equal to R1 plus R2 plus R3. Next, we will study about parallel combination. Parallel combination of resistances. See how the resistors have been joined. Now, very quickly just answer one of my questions, that what is the basic difference in connection in both these cases, like the series one or the parallel one? Let me quickly get back to the series circuit. Let me clear it a little bit for you so that you can see it properly. Okay, now tell me, see how the resistances have been joined in this particular part. This is a series combination. Now compare it with the parallel combination. See, once more and check it out again. Can you sense the difference? Both the ends of the resistors are joined. In the previous case, one end of R1 was connected to one end of R2 and the second end of R2 was connected to one end of R3. But in this case, both the ends of R1 are connected to both the ends of R2 and then both the ends of R3, isn't it? So this is how a parallel combination looks like. Now let's understand it a bit more detail. So when two or more resistors are connected between the same points, they are said to be connected in parallel. Now the features about parallel combination. When a number of resistances are connected in parallel, then the potential difference across each resistance is same, which is equal to the voltage of battery applied. This means you can see that a battery has been connected. If it is providing a potential of V, then the same potential is applied across each of these resistors. So the potential drop across every resistance is same. Now what about current? Different amount of current flows through each resistance, which depend on the value of resistance. But the current flowing through each parallel resistance taken together is equal to the current flowing in the circuit as a whole. Thus, when a number of resistors are connected in parallel, then the sum of current flowing through all the resistances is equal to the total current flowing in the circuit. Now, let us understand this. You can see that total current is marked as I Now once it reaches position A, there are three different paths, isn't it? See, this one, and this one. So since there are three different paths for current to flow, so there will be a branching. So suppose through R1 current I1 starts flowing. Through R1 I1 is flowing. Through R2 suppose I2 is flowing. And suppose through R3 the current flowing is I3. So I1 plus I2 plus I3 is equal to I. That is the total current. See, at point B again the three values for current are totaling up, and then the total current starts flowing in this direction. So total current I is flowing into A and then coming back from B. So this is what a parallel combination is all about. So let's again find what should be the total resistance when three resistors R1, R2 and R3 are joined in parallel. So as I is equal to I1 plus I2 plus I3. Let me again mark it for you. I1, this current is I2 and the current flowing through R3 is I3. So I is equal to I1 plus I2 plus I3. Now we will use Ohm's law. So from Ohm's law, I1 should be V divided by R1, I2 V divided by R2 and I3 V divided by R3. So this is equal to the total current I. So total current is V by R, and following the same tradition, let's put a subscript P. P stands for parallel. So V is the total potential difference applied by the battery. So V divided by Rp is equal to V by R1 plus V by R2 plus V by R3. Now taking out V as common, V by Rp is equal to V and then 1 by R1 plus 1 by R2 plus 1 by R3. So you can cancel out V from both the sides, and hence you get 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equivalent resistance in a parallel circuit. Now let's get a very quick understanding of both the type of combinations as to how it actually operates. See how current flows through a series combination of resistances. As I was telling you, there is a single path for flow of current. See, this is how it functions. There are three resistors R1, R2 and R3, and this is how current is flowing through. Same current is flowing through all the resistances. But what if they are joined in parallel? See, this is how current will be flowing through the circuit if the resistors are joined in parallel. There is branching, and see, I has branched into I1, I2 and I3, and again it joins together to give the total current, and the same potential is being applied across all the resistors. Okay. Now a question arises, if we have to compare between series and parallel combination as to which one is a better option, then which one will you choose? The series combination or the parallel combination? Now see, in a series combination there is only one path for flow of current. So obviously you cannot operate all the appliances separately. See this situation? If the plug is switched off, all the appliances get switched off together. Now that would pose a big problem, isn't it? Similarly, If any one of these appliances stop working, if any one stops working, the path will be broken, the circuit will be broken, and all the other appliances, even though they are in good condition, they will stop functioning. So these are the problems with a series circuit. But this is not so in a parallel combination. In a parallel combination, since current has got different path for flowing through the circuit, so even if one appliance stops working, current has got the other two path open for it. So it can easily flow through the other appliances and the other appliances will continue functioning as usual. Now there is one more advantage, that all the appliances are working on the same voltage and they are drawing current from the circuit as per their requirement, since same current is not flowing through them. So that's the main reason why in domestic circuits in our homes all the appliances are joined in parallel, not in series. So today's discussion will be ended at this point. Thank you.